4, there is 5, there is 2, and then 6, 7. Got it? Digital numbers of this. So what if you are pressing 7, that computer doesn't understand that 7. Computer understands this. So you need to have, if you would like to see 7 at output, the computer has to get this 111. Okay. For example, so these are the outputs, right? And these are the inputs. Take a note that in an encoder circuit, only one input can be activated at a time. Is activating at a time. You cannot activate several inputs at a time. I'm giving you an example of that. If this is a keyboard, if you are pressing 2 numbers at a time, you see only one is appearing at the screen. If you are pressing 4 or 5 at a time, you see only one is there, because the one, it can be activated at a time. So you cannot have 2 different numbers, 2 different buttons activated at a time. That means in a keyboard,
type Control Alt or Control Shift.
that is operator. That is not the inputs. That will operate. For example, the operator there are some instruction. You will learn about that. Maybe in machine code or assembly language, you will like this 9E. If you are pressing 9E, that means it indicates SASF. That means shift the contents of AS register into flag. That means inside your computer microprocessor there is a register that is called general purpose register. So that is A high, A low, B high, B low, C high, C low, D high, D low. Then there is a temporary register. Then there is arithmetic logic unit. Then there is flag register. So there are connections in between, right? Interconnection. So the data can transport in between. So now if we'd like to add one number with another, or multiply one number with another, or any activities that you would like to perform using your microprocessor, then the data are there in the memory. Do you understand how things are saved in the memory?
Yes, sir.
In a PC? Okay, I'm just showing you. This is the memory. The memory has got different sections. That is called segment. Okay, this is the total memory, right? But if I am just throwing all the data to this memory, some will be stored in that corner, some will be stored in that corner. Then when you need it, you will not find it. Then you have to search for it with this torchlight. So it's not possible. So computer is, if you search for something, computer is giving you within a matter of microsecond, right?
Yes, sir.
How it is doing that? So let's see how. It is segmented the total register into different segments. Okay, let us name it the segment, which is maybe segment 001, segment 002, segment 003, and segment 004, and maybe this 000. That is the name of the segment. So that means if I say the segment 003, which means this segment, this line only, right? And then this is called offset. The columns are called offset. So that means this is offset A, offset B, offset C, offset D, offset E, offset F, offset G, something like that. And now, for example, I'm telling that I would like to store RONY inside the PC. So RONY R, okay, maybe RONY RONY, for example. Okay, one bit can be stored. So I am just taking R. Now the physical address of RONY is the data. Physical address structure is segment dot offset dot data. That is the physical address of PC. That means the specific location of any data that we are putting inside our PC, inside our register. So I'm just giving you a lecture on something digital. That is why I'm making you understand this. listen, so digitally it is saved here, not R. You will not see R here, some digital numbers here. So that maybe R digital number is 1, 1, for example, or something 1. That is the R, the digital number of R. So it is saved here. So if you would like to find RONY for now, then what would be the address? Exact address. Like segment is 002 dot offset is E, and then data is 1. You understand? So that is how this is the offset and segment address makes your memory location. Now if I would like to add RONY with something else, right? Then I cannot add it directly here. I have to take this RONY to flag, right? I have to take it to, from this register, maybe it is saved in this register. So I have to take this RONY to flag, and then I can add something, I can give more inputs, and using this arithmetic logic unit, I can add it with RONY. And once it is added, I can save it to the memory. So that is how it occurs. So this instruction means shift whatever is there. You program shift what? This location. It doesn't understand RONY. It just understands this location. That offset and segment, that means 002E. Whatever the contents of this register location will be shifted. Let's shift the contents of AS register into flag. This means shift the contents of AS into flag. I mean F. S for shift the AS that means register AS, and into F that means to the flag. So that is how this code indicates this job done. This code indicates this job done. Okay.